So in our last tutorial, we computed a 90% confidence interval for the population mean in a particular circumstance where we had a known population variance of 6.25. We were taking a sample size of 49. And in our sample, we had a sample statistic for the population mean, which was the sample mean, and that was equal to 182. And in that tutorial, we constructed what we called a 90% confidence interval for the population mean, mu, and this ranged between the values of 181.41 up to 182.59. But importantly, this represents the sample mean and then 1.645 standard deviations to the left, up to the sample mean and 1.645 standard deviations to the right. And so let's let this be our sampling distribution. So this is distributed normally with a mean mu, as we can see, but with the standard deviation of our sampling distribution 5 on 14. And the question we asked in the previous tutorial was, well, how many standard deviations do I need to be to the left and the right of this mean to capture 90% of all the values? And we know that's going to be 1.645 standard deviations to the left and 1.45 standard deviations to the right. And so we've gone from looking at this in a standard normal to looking at this in a non-standard normal with mean mu and that should be variance of 5 on 14 squared. All right. And so we can go 1.645 standard deviations to the left, which get mu minus 1.645 times 5 on 14. And then we can go 1.645 standard deviations to the right, and that's going to give us mu plus 1.645 times 5 on 14. And we know that in a standard normal distribution, the values between minus 1.645 and positive 1.645 constituted 90% of the possible values in that standard normal. And that's going to be true here when we go 1.645 standard deviations away from the mean of the distribution. And so we can write that this is going to contain 90% of all possible values. And so there's going to be 5% of values in here and another 5% of values in here. And so our question is, why do we interpret this interval as having a 90% probability, a 90% chance that in general such an interval is going to contain the population mean? Well, the first thing I'd like to point out is that by construction, the size of this interval is the same as the size of the interval around the true population mean, which contains 90% of the values. Okay? And then I'd like to point out the fact that this sample mean here, in this case it's going to be 182 specifically, is just a draw from this sampling distribution. We covered this earlier. And so for example, a random draw from this sampling distribution could be here at x bar 1, it could be here at x bar 2, or here at x bar 3. It could be anywhere with different probabilities determined by our normal probability density function. And so because by construction the length of this confidence interval is the same as the length of this interval in the true distribution that contains 90% of the values, and so 90% of the values are contained in this length interval in the true distribution, and this is the length of an interval for a 90% confidence interval, okay? Because these are the same length, we've got to figure out a criteria for when the confidence interval around a particular sample mean is going to contain the population mean. So let's look at x1. And if we construct a 90% confidence interval around x bar 1, well, it's going to be the same length as this interval here. And so we can sort of take this length and say, okay, well, the same size interval around x1 is going to go sort of from here to here. And that does contain our population mean mu. Okay. And we can do the same thing with x2. We can say, well, a 90% confidence interval is going to be this length, okay? and it's going to go from here to here, and it is going to contain mu again. But now, let's look what happens when we construct a 90% confidence interval, i.e. an interval of this length, around x bar 3. And it's going to be of this length, and it's going to go from here to here. And notice it doesn't contain the population mean. So what determines whether the confidence interval contains the population mean? Well, the length of the confidence interval is simply the length of this 90% interval. And so whenever a sample mean is inside this 90% interval, the relevant confidence interval around that sample mean will always contain the population mean, which is the situation we had with x1 bar and x2 bar. But when a sample mean is outside of this 90% probability interval, such as in the case of x3, the corresponding confidence interval around that sample mean won't contain mu. And this is because the distance from the middle to the left, or the right of the confidence interval, is equal to the distance from mu to the edge of this 90% probability interval. And so if we're not within the probability interval, then our confidence interval won't contain the true mean. And so why do we say that there's a 90% chance that the true population mean mu is contained within a random 90% confidence interval? Well, when we choose a random confidence interval, we're really just choosing a random sample mean. And notice that 90% of our sample means are contained within this length probability interval, and those will always contain mu within their confidence intervals. But 10%, 5% to the right and 5% to the left, of our sample means are outside of this interval, and so their confidence intervals will never contain the population mean mu. And this leads to the interpretation that there is a 90% probability that mu is contained within our confidence interval. And this is because when we look at our sample mean, there is no way for us to determine whether it is close enough to the mean or far enough to the mean to contain or not contain the population mean within its confidence interval.